So in problem number 1, it says graph each function, identify the axis of symmetry. So I'm going to just do a rough sketch since it says graph. So we have our XY chart. I take my calculator and I just type it in. So I'm going to pull it up and type it in. And I know you know how to type it into your calculator, so I'm probably actually not going to spend the time doing that. But if you graph it in your graphing calculator, it looks something like this. Now I go through and use my graphing calculator to find the vertex, and in this problem it's a minimum. So I do second trace and I find the minimum. And I do a left bound, which would be over here, a right bound somewhere over here, and then you'll find the vertex, which is at the point 2, -5. So that's a good enough sketch of the parabola. So we went over 2, down 5, and there's our lowest point. Now our axis of symmetry is where it's symmetric. So if you drew this line in, do you see how if you grabbed it and fold it like a sandwich over that line, it looks exactly the same? So our axis of symmetry would be x is equal to 2. This is our axis of symmetry. X is equal to 2. So in this next one, once again, it says graph it and then identify the axis of symmetry. So I graph it and it looks something like, if you type it into your graphing calculator, it looks something like this. Once again, I do second trace to find the vertex, which is either the highest or lowest point. This is a maximum. So make sure with this one you do second trace to find the maximum value. Our left bound will be over here, our right bound will be over here. And you'll get this point, and this point is at, it's at -3 up 4. Okay. So then our axis of symmetry is right here at the x value. X is equal to -3. That's all you have to do on those ones. So we did a rough sketch and then we found the axis of symmetry, and it's always the x value. Okay, with number 2 it says find an equation in standard form of the parabola passing through the following points. First of all, keyword, it says parabola. Parabola means quadratic. Also, we could use the n+1 point principle. If there are 3 points, then there's 1 less than that degree. So we know this is degree 2. But also in the instructions, it did say the parabola, which means quadratic, so degree 2. Then we do stat, edit, remember in our calculator, so stat, and then into edit. And then in list 1, you put in your x values. In list 2, you put your y values. So in list 1, you'll do 0, 1, and 2. In list 2, you'll do -4, 1, and 8. Then you'll do stat calculate. Instead of edit, you go over to calculate, and then you scroll down to quadratic regression line. If you type it in correctly, it's going to give you an A value of 1, a B value of 4, and a C value of -4. So we know that that means that the quadratic has an A value, so it's going to be 1x squared, or just x squared, and then my plus 4x, and then it looks like -4. So this would be our final answer right here. This is our polynomial, our parabola, that passes through these 3 points. So we do the same thing over here, and if you do that, you will get the answer. You'll get A value is equal to -1, your B value is equal to 3, your C value is equal to 5, so you'll get -x squared for -1, and then plus 3x, and then plus 5. So this would be your final answer. Okay, it says factor, or rewrite each expression in factored form. So that means factor it. Now remember, factoring a polynomial just puts it in a different form. It's the exact same thing, it's just in factored form. So first things before we do anything here, we put it in standard form. So I have -t squared minus t plus 20. Now from here you could do what multiplies to be a times c and adds up to be b. That's one way of doing it. I decided, okay, I want to be able to quick factor, so the first thing I'm going to do is factor out that negative. So I factored out -1. Now when you factor out -1, you go to divide each term by what you factored out, so that's going to leave me with positive t squared, and then plus t, and then minus 20. So then from there, I'm just going to focus on my inside and factor it. Now that I've done that, my a value is positive 1, so I can quick factor. So that's why I chose to factor out the negative in the beginning. But you could have done it this way. You could have done what multiplies to be negative 20 and adds up to be negative 1, but then you would have had to do long factoring due to the fact that our a value is not positive 1. So where I factored out the negative 1, I've now made it easier on myself. So now I'm focusing on the inside, and I'm looking at what multiplies to be 1 times negative 20 and adds up to be positive 1 from that b value right there. So we know that the factors are 5 times 4 and must be a negative 4. It needs to add up to be positive 1. Because our a value is positive 1, this is going to quick factor to be a binomial with these two factors. So we'll have a t. We're going to have a plus 5 due to the fact that that's positive 5, and minus 4 due to the fact that that's minus 4. But don't forget that this negative 1 was also a factor. So our final answer will be negative 1 times t plus 5 times t minus 4. And if you would have done it the other way, the long way, you would have got the answer negative t plus 4. So if you would have done it the long way, that would have worked out, but you would have got this as your answer, negative t plus 4 times t plus 5. And technically, because the negative in front is means it's not simplified, so our last step, if we would have done it the long way, is factor out negative 1. That would have left us with t minus 4 times t plus 5. So same thing, same answer, just different ways of getting there. I just did it this way. Okay, once again, number 3, it says write in factored form. So we notice it's quadratic, and there's nothing in common in all 3 terms. So I'm going to go ahead and do what multiplies to be a times c, which is 225, and adds up to be 30, positive 30. So then I list out factors of 225. I had to sit and test them. I did 225 divided by 2, 225 divided by 3, 225 divided by 4, and I finally came up with the factors 15 times 15. Those multiply to be 225, and they add up to be 30. So then we drop and break. So we drop down 25w squared. We drop down positive 9. And then we're breaking down our middle term, rewriting it as these two factors, but with a variable. Plus 15w plus 15w. Then you group the first 2 terms. We group the second 2 terms, including the sign. In this group, the greatest thing in common is 5w. So then left-hand side divides each thing by what you pulled out. Left-hand side was 5w plus 3. In this group, the greatest thing in common is positive 3. So I pull out a 3, divide each thing by 3. We get 5w plus 3. Check your safe haven. It better be exactly the same, or you factored something wrong, or your factors aren't right. One of the two. So because our safe haven's good, it's the same, we can pull it out. Now when we pulled it out, we technically divided it out. So then left was 5w plus 3. And so you could write it like this. I'd accept it, but also I'd accept, even better, is this answer, 5w plus 3 squared. On number 4, it says complete the square. So what you do when you complete the square is you take your b value and divide it by 2 squared. Our b value in this one is 9, so we take 9 divided by 2 squared. That's a decimal. Let's change it back to a fraction. So 9 divided by 2 squared is 81/4. So that's the square that we're inserting into our equation. Now you always insert it in after your bx. So there's our bx. We're inserting it in right here. So we're going to have x squared plus 9x, and we're inserting this in, so plus 81/4. Now if you add that, you've changed things. So you got to fix it by subtracting off that same amount. So once again, remember, we're really just inserting a fancy 0 here. That's really just a 0, just a really fancy 0. So we haven't changed anything. So technically we have plus 0, so if we wanted to, we could write plus 0 here. Then you group the first 3 terms, you group the last 2 terms, and you factor these. Now remember, the factoring part's easy. You always look back inside your parentheses, your b divided by 2 before you squared it. That was positive 9/2. So this is going to factor to be x, and since it was positive 9/2 plus 9/2, and it's going to be that twice, so that's squared. And then we add this piece, so negative 81/4 plus 0 is negative 81/4. And now notice, this is our answer. It's just now from standard form into vertex form. And we do that by completing the square. So our final answer will be this. All right, so there we go. So now, first things first, I didn't say this on this one. We could do this so quickly because our A value is 1 right up here. But in this one, our A value is 4. So the first thing we're going to do is factor out of 4. So I factor out of 4. Now I divide each term by what I factored out. Left is x squared minus 3x. And then technically, I guess you could say we have plus 0. So then from there, you take your B value, which is negative 3. You divide it by 2 squared. Once again, I'm not going to write that as a decimal. I'm going to write it as a fraction. And the fraction of that is 9/4. Now you insert that in after bx always. So it's going in right there. So we're going to have x squared minus 3x, and then we're going to add 9/4. So add 9/4. But if you add 9/4, you've got to subtract 9/4, and then we still have our plus 0. Then from there, you group the first 3 terms, you group the last 2 terms, these you factor. You can use your little trick, look back inside the parentheses before you squared it. It was negative 3/2, so this is going to factor the x minus, because it was negative 3/2 squared. And then we add these two, so negative 9/4 plus 0. The reason I did the 0 is it's not always going to be 0. Like, what if that would have been plus 2? We would have had we would have factored out our 4. So let's say that was, for example, plus 4, and we factored out a 4, then left would have been a 1, we would have added 1 right here. So that's why I'm just showing you the plus 0, is because if it's not 0, you'll have to make sure you add that together. So negative 9/4 plus 0 is negative 9/4. And now it's almost in vertex form. We just can't forget about that 4 that we factored out in the beginning. Now the 4 was factored out of the whole thing. So you've got to go back through and kind of multiply it in. Now 4, we'll leave the 4 times x minus 3/2 like that. 4 times x minus 3/2. Because that's prettier, that's more in vertex form. We don't need to distribute the 4 in. In fact, we couldn't put the 4 inside, because then we'd be squaring 4, which is incorrect. But we've also got to multiply that 4 through times negative 9/4. If you need to do it in your calculator, you can. 4 times negative 9/4, and you get negative 9. And now we've distributed our 4 through to each piece, so we're good. So this will be our final answer here. Now, once again, the most common error is most people forget about that 4, or they forget to distribute the 4 through to each thing here. Okay, so this would be our final answer in vertex form. Okay, on number 6, I'm going to skip number 5. You can hopefully do number 5. Explain why they're the same, and then also, explain why this is so. So if you solve each of those, you get the same x values. That's why. And then also explain how the y coordinates are related. So you'll find the vertex of each of those parabolas and then compare them. Are they the same? Are they opposite? Like, what is it that's very unique about those y values of the vertex? Highest point, lowest point. So I'm going to do number 6. It says, a student says that the graph of the parabola y equals x squared plus 101. So this function is 1,000 times larger than this function. Well, why is that an error? Because if we think back to how quadratics work here, if we wanted to graph this is actually our shift, since it's not being added inside with x, and since it's not being multiplied to x squared, it's just being added. That literally takes our parabola that used to be right here, and it shifts it up to 1,001. So it shifts it up to 1,001 units. It shifts it up. So there was no shift left and right, but there was a shift up and down. So we went up 1,001. Now this parabola over here is a quadratic that's just been no shift left and right, but it shifted up 1. So it used to be right here. We took it and we shifted it up 1 unit. So it's at 1. 1 comma, or over 0 up 1, and this is over 0 up 1,000. So it's not 1,000 times larger, it's just shifted. It's not 1,000 times larger necessarily, it's just shifted 1,000 units higher. So this one's just shifted up to 1,001, and this one was only shifted up 1. So it's shifted 1,000 units higher. So hopefully that makes sense. So you'll just say it's not 1,000 times larger, it's just shifted 1,000 times larger. In fact, it's the exact same parabola, it's just been shifted up 1,000 more units than this one. On this next one, it just says solve. So, what kind of polynomial are we looking at here? Well, it's quadratic. So we know how to solve quadratics. There's many different methods of solving a quadratic. You can try solving by factoring. If it's factorable, you can solve using the quadratic formula. Always, but before we can do that, we have to make sure it's set equal to 0. It's set equal to 6. So I've got to bring the 6 over very first. So it has to be in standard form, a quadratic, and set equal to 0, and then you can do it. So our A value is 1, our B value is 4, our C value is -6. I'm going to use the quadratic formula. So x equals -4, negative b, plus or minus the square root of b squared. So 4 squared minus 4 times a, which is 1, times c, which is -6. And then that's all over 2 times a, so 2 times 1. So we have -4 plus or minus the square root. If you type this into your calculator, you can actually type in this whole piece as long as you use parentheses around everything. Like, type it in almost like exactly like this in your calculator and you should get it right. And if you do that correctly, you get 40. So all over 2. And then from there, we go off to the side and say, I know how to break down the square root of 40. 40 is 4 times 10, 4 is 2 and 2, 10 is 2 and 5. Because it's a square root, we pull out groups of 2. So there's 2 2's that can leave the house, that must stay, that must stay. So we have 2 square roots of 10. So square root of 40 just became 2 square roots of 10. So I'm going to rewrite this again. -4 plus or minus 2 square roots of 10 all over 2. And then you can look, do all 3 things divide by something? Well, yeah, they all divide by 2. So this divides by 2 and becomes a 1. This divides by 2 and becomes a 1. This divides by 2 and becomes a -2. So it finally simplifies to be -2 plus or minus 1 square root of 10 is just square root of 10. 1 times the square root of 10 is just the square root of 10. And then all over, well, divided by 1, anything divided by 1 is just itself. So there's my answer. And there's 2 answers, which makes sense because it's degree 2. So there's our quadratic. We've solved it and simplified it correctly. Same thing with number 7. It says solve. You can solve by whatever method you'd like. I'm going to use the quadratic formula again. A is equal to 1, B is equal to 3, C is equal to 8. So we do x equals -3 plus or minus the square root of b squared minus 4 times a times c all over 2a. So we have -3 plus or minus the square root. If you type this incorrectly under here, you better get, if you type it into your calculator, you better get -23. And that's all over 2. So then you go off to the side and say, can I simplify -23? Well, there's no factors of 23 besides 23 times 1. So we can't pull out the 23, but because there's a negative under there, we do pull out an I. So that's I squared root of 23. So what we really have then is -3 plus or minus I square roots of 23 all over 2. And then all 3 things don't divide by anything. So this would be our final and prettiest answer. Now we have 2 answers. They're both imaginary answers. And that makes sense. We should have 2 answers because it's degree 2. So in this one we had 2 imaginary solutions. And notice they're conjugates of each other. Okay, number 8. Solve each system of equations. So there's a couple different ways you can do this. You can either do it using your calculator. So if you do this using your calculator, you're going to have your parabola. You're going to have a parabola, and then you're going to have, so then you'll have a line, and it intersects in 2 places. So you would do second trace, and you'd find the intersection points, and that would be like, for example, they intersect at x is equal to 1, and they intersect at x is equal to -5. Now that's one way of doing it. If you do it that way, that's totally fine, but you've got to make sure to go through in that case and check your answers for extraneous solutions. So you got to plug those back into both equations and make sure that it comes out correctly. So I would just be really careful doing it that way. That's one way of doing it. But you got to check your answers. So you'll check your answers once again by plugging in a 1, and you better get the y value, which, let's see. If I did it in my calculator, I should have wrote down. So we got x is equal to 1, but it was at 1 comma some number. And then so you would plug in a 1 into your equations and check to make sure it comes out correctly. Or really what I would do instead is check it this way. So we have negative x squared minus 2x plus 8. When is it equal to 2x plus 3? I just plug in those values actually. I plug in 1 and negative 5 back into this to check your answers. So that's one way of doing it, is using the calculator. I just do it algebraically. So I say, okay, if they're both equal to y, then they're both equal to each other. And then I'm going to just combine my terms. So subtract 2x, subtract 2x. So I have negative x squared minus 4x plus 8 is equal to 3. Then I'm going to bring 3 over, minus 3. So I have negative x squared minus 4x plus 5 is equal to 0. And now I know how to solve a quadratic by hand. So I do what multiplies to be, well, I'm going to factor out negative 1. Then left is x squared plus 4x minus 5. So now I'm going to solve the quadratics, and the reason I factored out the negative 1 is so I can quick factor it. So I'm looking for what multiplies to be negative 5 and adds up to be 4. So that'd be 1 times 5, negative 1. So this factors to be x minus 1 times x plus 5. So then I can set each of my factors equal to 0 and solve. Even with that negative 1 out here, I'll just set my factors each equal to 0 and solve. So I have x minus 1 is equal to 0, x plus 5 is equal to 0. So x is equal to 1, x is equal to negative 5. Now what do you know? We got the same answer algebraically that we did as if using the calculator. So really it's just kind of your choice. The only reason I like to do it algebraically is just because I'm an algebra person, and sometimes it's hard to not miss something if your window's not big enough. This way, algebraically, you never miss anything. So once again, you have y is equal to, I should have wrote this a little bit prettier. So we have y is equal to 2x squared minus 3x minus 1, and y is equal to x squared plus 2x plus 5. So we could do this a couple different ways. You could either graph it and find the intersection points. There are 2 intersection points. And then you would check your answers and then throw out any extraneous solutions. But I'm just going to say, okay, if they're both equal to y, then they're both equal to each other. So 2x squared minus 3x minus 1 is equal to x squared plus 2x plus 5. So you could graph it in your graphing calculator, see whether equal, then check both your answers. I'm just going to do this algebraically, I think. So I'm going to subtract x squared. So I have x squared minus 3x minus 1 is equal to 2x plus 5. I'm going to subtract 2x. So then from here I have x squared minus 5x minus 1 is equal to 5. I'm going to subtract 5. So x squared minus 5x minus 6 is equal to 0. And then I know how to solve a quadratic, so I'm doing what multiplies to be a times c, what multiplies to be negative 6, and adds up to be negative 5. Okay, so it'd be 1 times 6, one of them would have to be negative. So I would put the negative with the 6. And because our a value is 1, this can quick factor. So it's going to factor to be x plus 1 times x minus 6. So I get set each of those equal to 0. So I get x is equal to negative 1 and x is equal to 6. So then I would check my answers by plugging them back in to the original problem. So I plug in negative 1 into all my x values and see if that gives us a true statement. And then I plug in 6 in for x and make sure it gives us a true statement. And neither of them are extraneous solutions. So our final answer will be x is equal to negative 1 and x is equal to 6. So you can either just use your graphing calculator to find where those are equal, where they intersect. That's one way of doing it, or you could do it algebraically like I did as such. Calculator way is easier, but you just got to make sure you check your answers. Okay, and the problem with the calculator, once again, it's fine. I would love for you to do it that way if that's how you're going to get it right. But you just have to make sure your window is big enough that you can see both intersection points or all the intersection points, because if sometimes people's windows are too small and then they miss one of the intersection points. So go ahead and use your calculator as long as you make your window really big and make sure that you don't miss anything. Okay, solve each of these. So we have 9r squared minus 1 is equal to negative 77. So notice this is a quadratic that we're solving. And notice we're missing our bx. There's no middle term. So these are easy. You just have to isolate r squared. So I'm going to add 1. So I have 9r squared is equal to negative 76. Divide both sides by 9. So I have r squared is equal to negative 76 over 9. Then to get r alone, we'd square root both sides of the equation. Root cancels out with power. R is equal to plus and minus. I'm going to split it up. On top I have negative 76. On bottom I have the square root of 9. So then from there I simplify each piece. I go up to the side and say, what is the square root of negative 76? That breaks down into 2 times 38. 38 breaks down into 2 and 19. And we're pulling out groups of 2, and we are pulling out the negative, so we have a 2i, and then left underneath is a 19, so square roots of 19. So the top became, so we have r is equal to plus or minus 2i square roots of 19, and then the square root of 9 is 3, so all over 3. So you just got to simplify each piece correctly. On number 9, we have negative 2 times x minus 3 squared is equal to 4. It's a quadratic we're solving, and it's in vertex form. So we have to isolate the whatever's in the squared part. We've got to isolate it completely first. So I'm going to divide both sides by negative 2. That leaves me with x minus 3 squared is equal to negative 2. And then I'm going to square root both sides. So I have x minus 3, our root cancels out with our power, and it's plus or minus the square root of negative 2. So really we have x minus 3 is equal to plus or minus, we pull out that negative, I square roots of 2. And then to get x alone, our last step would be to add 3 to both sides of the equation. And the pretty way to write it, the correct way would be to say, well, it's positive 3, and it's plus or minus I square roots of 2. This would just be writing it in pretty form. Because that's how a rational is written, or I'm sorry, an imaginary number is written in the form of a plus bi. So technically we would write it the 3 first, just to make it prettier. Okay, solving. Once again, this is a quadratic, and so we isolate the whatever squared, divide both sides by 3. So we have x minus 2 squared is equal to 3. Because we want to undo the square, we square root both sides. So we have x minus 2 is equal to plus and minus the square root of 3. And then we're going to add 2 to both sides. And once again, the pretty way would be to put that positive 2 first. So I'm going to write 2. Then it was plus and minus the square root of 3. This is how an irrational number is written. It's a pretty way of writing it. So the whole number part comes first. Okay, x 4 times x minus 1 squared minus 5 is equal to negative 25. It's a quadratic, it's in vertex form. These are pretty easy to solve. We've got to isolate x minus 1 squared completely first, though. So we have 4x minus 1 squared is equal to negative 20. Divide by 4 first. We've got to isolate it completely. So we have x minus 1 squared is equal to negative 5, right? And then we will square root both sides of the equation. So we have x minus 1 is equal to I square roots of 5, and we can't forget the plus or minus. I kind of jumped ship on that one. I simplified that and all at the same time. So we pulled out the negative, it was I square roots of 5. And then we add 1. The pretty way of writing it is to put that positive 1 first. So 1 plus or minus I square roots of 5. So this would be our final answer. Now be careful, if this would have been minus 1, let's say I changed it to minus 1, like what if this would have been a plus 1 under here? Then we would minus 1 from both sides of the equation instead of plus 1. then make sure you write it. It would have been -1 plus or minus I squared roots of 5. So just be really careful. It wasn't, but just on a side note besides that, just be careful with something like that. And that is all for pages 1 and 2.